Hello, everybody, and welcome to the 17th appointment for chapter 17 as well of my book, Computational Structural Engineering. And here we show some advanced examples, and we will use all the techniques that we learned in the rest of the book. We start with wheel bearing simulation. Okay, this is clearly a Formula One wheel bearing, and it is suggested how to model the non-linearity of the bearing, but this approach can be used, of course, for any kind of bearing that one may have to introduce in its models. It is shown also how to extract forces in the balls, how to get contact pressure without simulating the balls themselves. And the example here shows how it was possible to optimize the behavior in terms of stiffness of the parts like the hub and the wheel bearing themselves. Different materials have also been used for the balls, like steel and ceramic. And the result in the end was that it was possible after the optimization to use ceramic balls, whereas up to that point they were not lasting a sufficient mileage. And by reinforcing where it was necessary all the parts involved, then the target of using ceramic balls in races was achieved. This as an example is quite funny somehow, because this it was coming from the same let's say project to increase the stiffness of the car, and the rim was needed to be optimized, but in order to do that we needed to have the correct introduction of the load into it. And so, because we had the model of the tire from the supplier, the idea was to put everything together, and the model of the tire was clearly reproducing the behavior of the construction of the tire, so with rubber outside and different stuff in terms of composites, strange composite of material, and clearly this was the know-how of the tire producer. The idea was to have three load cases, so pressure inside, then pressed on the road, which is shown here on the track, plus then adding a lateral force coming from the forces were coming from the data on telemetry on one of the most loaded corners, fast corners. And the thing is that at that time, so early of 2000, the model in the lateral condition was not converging to the force value, the desired force value, mainly because of distortion of the elements, so the mesh was not fine enough in this area, and so it was coming to numerical errors. But I have taken this back, and the thing I have found is that it was not only converging, but it was converging in 11 minutes on 8 CPUs, and at that time it was running, of course, on one CPU, and yeah, it was taking 14 hours to not converge. So just to say that 20 years have not passed for nothing. And yeah, here are some results. So the contact pressure coming from just pressing it vertically, plus then the behavior of the contact when also the lateral force is applied. And that's it. It was an interesting problem to be shown, which combines also some hyperelastic elements from the rubber. And then a lot of words are spent on this example, which seems to be maybe trivial, but actually it is not. So two plates bolted together, and with a bolt which is preloaded, then contact pressure between the plates is analyzed, Then we also try to separate the plates by pulling the bolt head. Then we try to separate the plates by pulling the plate, one of the plates, while the other remain constrained. Then we try to pull only on one side to see again the prying action, what is changing, and everything is done trying to compare with with the analytical results whenever possible, and it's not always possible. Then also shear forces considered, trying to make one plate to slide over the other, and this is done again showing contact pressure, shear stresses which arises there, and then by simulating the material, nonlinear material properties of the bolt, we also go up to the point where the shank of the bolt is coming into contact with the holes, and then the different behavior are here given to interpret what is going to happen. Residual stresses are present, what is the axial load which is acting on the bolt starting from the preload, etc. So it's quite analyzed quite deeply, up to the point where using the explicit approach and the material damage model of the ductile material which constitutes the bolt, it's taken up to failure. And here the comparison between the implicit approach and the explicit approach is given. For the implicit, the material, the model of the damage for the material was not considered, so it's going up, whereas for the explicit, which is the red line, at a certain point the failure happens and then the forces drops. Then we switch back to the example which is already has been shown in chapter 3 and then 10, and now here it's calculated in its complexity or in its totality. So we model the part where the bracket is pressed onto, and we model with solid elements the bolts, which means that then we have to model the contact between the bolt and the bracket and the plane, of course, and we can also consider the preload. We start without the preload because the linear model we used didn't have it, and we extracted the section forces to be compared with the ones we obtained when the model was constrained with MPCs and beam elements to simulate the bolts. Then a comparison is done, then the preload is also considered, and the difference are explained and highlighted. Then also lag analysis is shown, especially in the three failure modes of three typical failure modes of the lag, which were mentioned in chapter 10. And the comparison is also given here with the theoretical values, and considering elastic plastic behavior, we see that there are some the differences that are coming from the pure linear model are coming close to the theoretical results. And then again, by simulating the damage of the material, we can simulate the shear tear out failure mode. And if we then reduce or increase the section by moving the hole a little bit more inside, so that in order to make the most critical failure mode the net section one, which is then what we see here. As I already said, blue description of the figures are inviting you to visit this link and to see the animation of what is happening. And basically that's it. Chapter 18, I would collect it here as well, because it's just a philosophical one, so there is not that much to show, and it has to be simply read. It's just some conclusions, some considerations on the state of the art. And in the next appointment we'll see the 3 appendixes, also these ones in one go, so to reduce the number of appointments. Then see you, I would say, at the next appointment, which will be the last one. Goodbye, everybody.